Maybe I should go back to the resize window so you guys can see exactly what I'm seeing here. Yeah, so I'm gonna switch my window size back. But yeah, that was such a funny mistake to be making. Uh, yeah, that was a pretty funny mistake to be making. Uh, um, yeah, so that's a pretty funny mistake to be making. But, one second. My computer on charge so it doesn't die. But, yeah, okay, just to step through the code one more time. Or, I don't think we actually need to step through. I think we kind of got it. Um, we all kind of got it. The funny part is that it was such a simple mistake in the end. I remember I was getting a little bit kind of frustrated that I couldn't find the error in my code, but it was such a simple error that if I just slowed down, debugged it really carefully, I would have got it like a while ago. Uh, yeah, I think setting breakpoints especially is like a really big learning from that because setting breakpoints is so helpful in figuring out why your code went wrong. I'm trying to resize my code editor thing so you guys can see it. It's not like tiny on my screen, and I'm just struggling to do this, bro. I guess I don't know how to. Okay, that didn't do it. I do not know why I can't resize this. To be 100% with you. Okay, I don't know why I can't resize it. Right now it's looking like I might have to just resize it like that and resize it manually. Uh, yeah, I don't know how I get it better than that. I'm sorry, boys. But that is what it is, I guess. Okay, so let's just talk about what we've done so far. Um, Here, let me just go to yeah. I'm on visual mode now. Um, okay, so let's just talk about the code so far. So the code so far implements is pivot and implements RREF correctly here. And another reason that I was doing it so wrong is I got a little bit lazy, I'll admit, and this happens when you get lazy. I asked ChatGPT to generate me the examples for my text, right? So it did. I put them in, and it was failing all the examples. And I check all the examples like manually by hand, and I'm like, ChatGPT's gotten all of these wrong. And I guess that's sort of a lesson. Don't trust LLMs with this type of stuff. Sometimes you gotta just do it by hand, or get one of those reliable calculators just to do it. Um, do it on a reliable calculator so you can know like what's up. So the next thing we're gonna do is I think we're gonna do an inverse by reduced row echelon form. So augment the matrix. We've sort of implemented that with this append function, which sort of appends takes in a list of a matrix and appends it to the matrix, returns itself, and then what we want to do is we want to run RREF on the augmented matrix to convert it, and then just read a minus one. So we've also added a generate identity matrix here that based on the dimensions that you want, it generates an identity matrix. So we could legitimately just go ahead and probably code this now. The generate identity matrix is like pretty simple. Like let's say the code is also like reasonably. It's like very trivial. Honestly, it's like very trivial. Um, ah, I'm struggling to get out of insert mode, bro. There's like something to it, I swear. I don't know why. Like whenever I'm trying to get out of insert mode, like there's like some like I think this is the thing I have. So so you're supposed to click I to go from insert to go to sorry, from I'm in like visual right now, right? So from visual to insert should be capital I. But I don't understand how I'm supposed to produce that. It's supposed to be shift I? Oh, it was shift I. Okay. So just to show we've as we've shown you before, we've implemented the dot show, right? So this just generates an identity matrix, like really simple. You could even do this without the whole you could do this just this should generate an identity matrix no matter what number you say. We could even it's probably not particularly efficient. Like if you gave it like a 10, it would probably get pretty inefficient. Or okay, maybe not 10. That's a little bit thing. But like if you gave it like 100, it would get a little bit inefficient. But I don't think we'll need to be working with anything that big quite yet. And we can think about efficiency a little bit later. So yeah, it gets pretty hard to read. Right once you get to like about 100. But yeah, we have the generate identity matrix working really well. That works, and we're able to generate identity matrices based on the dimension we need. We're able to append them. So now we can start working on. I don't think we really need to test this. I've already just coded up some simple tests for it, and it seems to be working. Speaking of, there's something with my enter key, bro. It's like goofed up somehow. Not sure, but okay. So if we're trying to inverse via REF, so maybe we just type that as REF inverse. Um, So yeah, so RREF inverse. Like I swear, I'll be clicking enter, and sometimes it just doesn't enter. It's kind of weird. I don't know what happened. Maybe I need to like remove it or something. Okay, so augment the matrix with an identity matrix of the same size of the same row size, right? Um, so um, so we just augment it by the by a thing with the row size, and okay. So let's just go into the how we're gonna augment it. Um, so the augmenting is pretty simple. Speaking of, I don't know why comments keep getting disabled on my live stream. I wish I knew. Also, speaking of, my whole like thing is like kind of goofy. Like when I click, like it feels like kind of laggy too. I don't know. Is it just maybe it's just me, or maybe I'm just being a goof or something. Uh, anyway, right? Uh, so the augmenting seems pretty simple. Yeah. Okay. So first of all, we need to take in the we're doing it of itself, right? We're using RREF to inverse. So we just check. We can just do self dot shape equals. I mean, we can set a tuple now, and we can do self dot um num calls comma num rows. Self dot num rows. So what is this gonna do? So we're currently trying to inverse the matrix using RREF. So as you guys see, so first we need to augment the matrix like this. So for example, if it's like if the matrix is like anyway, yeah. So if the matrix is like for example like 2 5 and then there's like let's say second row matrix is like 3 comma 2. When you're augmenting it, basically what you're saying is you're creating this matrix into a matrix where it'll be this, and you're just basically appending on the thing. So it's pretty simple. So then we just do um so we just do self dot generate identity matrix. So let's just be a little bit lazy here. Let's just do im is equal to. We don't need to do anything particularly complicated. It returns a matrix, which is nice. Uh, so now that we have generate identity matrix, we have our identity matrix generated. We can actually augment, right? So augment is just basically appending. So we can just do, um, so we can just self dot append, uh, and here we just need any of the dimensions because we're assuming it's actually we need to just do a quick check for that. So if self dot num columns, so if the number of columns is not equal to the number of rows, then we know that we have to raise a value error because this should only be happening to square matrices. Oh my god, this should only be happening to you should only be trying to take the inverse of a square matrix. But so we've generated the identity matrix, and we'll just say it's by the number of rows. So let's do it. Let's just say it's self dot num rows. We can do self dot shape, but it's really helpful to have self dot shape. We know honestly we need to just implement this in the actual matrix thing. Like that would be kind of helpful in the future. In case you ever want it, we need to have like all this stuff accessible because you never know, and that'll probably make it better for people more used to using like NumPy like me. Like I'm so used to doing self dot shape dot 0 when I want the x value, self dot shape dot 1 when I want the y value. Okay, so now we're appending, and we just do the matrix in the form of a list. So you just do im.matrix, and it will turn it into a list. So once you append it, you'll have the augmented matrix. So now you need to run RREF on this. Run RREF to convert it to that. So self dot RREF of, and it'll run it on itself. And then let's just do self dot show, and let's just make sure that the correct thing is being run. So let's just do L dot RREF inverse. So that is a square matrix, so it should probably be fine. So let's just test it out. Oh yeah, this isn't actually being called because of that. We forgot the parentheses. Pretty simple. Whoa. Okay. Um. So, all right. So we need to actually like check like why this isn't working. Uh, so actually, what's happening here is actually intentional because this matrix is not invertible. It's just not invertible. So let's change to a matrix that is invertible for actually, so it actually is able to like compute everything. So we can actually find something. I mean, it was a pretty funny error for a bit because I was like, I was thinking, and that was the reason I was kind of silent. I was like, okay, so we need to debug either. Well, we've just run a ton of tests, and we've just fully debugged what we thought to be the RREF reduced row echelon form algorithm working correctly, and I'm like, so it's not working. I might have to re-debug it, go back through it, make sure I run more tests or do something. But turns out we don't have to do that, which is really nice. Okay, so why does it dot show twice? When I do self.rref, does it show at the end? Oh yeah, I added a self.show for some reason. Get that out of here. Let's just rerun it so we don't have to. Yeah. Okay, so the identity matrix is here, and yeah, so this should just be the inverse. Um, that's pretty easy to sort of extract. So you just all you need to do really is self.matrix. We're looking for the inverse, so we do self.matrix. So you take the matrix that we have here, and then you know the number of columns, so you do self.numRows. Sorry, numRows should work. Yeah, so we want all the rows. So actually, so we can just do colon, and then we want all the rows, but we only want the columns starting from self.numCalls plus 1, and then we want everything else. So let's just do self.show now. And then let's just say new matrix list equals blank, and then or not list. Let's just say output. Let's just keep it consistent and have the output be the output. Maybe in some of our previous ones, we need to just also do that so there's a consistent way to refer to the output of a matrix. So we just need to do output.show. So this could legitimately just fix all our problems here. Um, hmm. So where's the problem here? Is it here? Maybe let's replace this with nothing. So instead of output.show, let's just do print output. Another thing I don't want to do is add feature creep, which I want to keep it relatively. So this is just wrong. So we just say something I want to do is I want to keep it like away from feature creep because I don't want to just be adding a ton of features all the time, and then I get to like the state where a lot of these features are useless. Um, I want to keep it relatively lightweight and like so all the features are at least used by someone at least I guess. So let's just take the first column there. Oh, it's not going to take by column. Uh, ooh. A nice way to do this is the get columns. So a nice way we've implemented before is get columns. So that gives a list of all the columns. So now we don't need all of them. We just need the ones from self dot num columns onward. So let's just try that now. Uh, and then let's just do self dot show for do. There's something with my enter key. I don't know what it is, but it's not particularly fun. Boom. And we've taken 0, 1, comma, negative 1, 1.0, 3.05. Yep, we've got the correct one. So let's return output. And obviously it has to be a matrix, and this allows for future chaining where you can do matrix.show and tons of other cool fun stuff. So I'm just gonna ask quickly, I'm just gonna check what the inverse of this function would be. Skip, 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 skip. Or I can just put it into a... So let's just quickly run the inverse.show, because this is kind of ugly, to be honest. I'm so glad. .show, I don't know, because it just makes it look a lot better. And remove this self.show. That's completely unnecessary now because we're doing something much superior. Yep. Uh, okay. So let me just Google up an inverse matrix calculator really quickly, just to make sure if our math is correct. So I don't know. I found some sketchy inverse matrix calculator, but this is a 3x3 matrix, and it's the 3x3 matrix we're passing in is going to be 2, 1, 1. Okay, so 2, 1, 1, 2, 1, 1, right? And then it's 1, 3, 2, 1, 0, 0, 1. Oh, you guys can't see my screen here. I don't know what calculator this is, but 1, 3, 2, 1, 0, 0. So let's calculate. So it's 0, 0, 1, negative 2, 1, 3. Huh. Alright. Yeah, this is definitely not right. Okay, so let's go to this step, and actually let's do something else. Let's see if okay, so so let's see if a couple steps before. Yeah, so this is what you should have gotten. 1, 1, 0, 2, 3. Let's just see what we do. Let's just do self.show really quickly. Wait. So if you get this, how do you get from... Huh. Okay. We need to think about this. This is probably an interesting problem. So let's do .show here. Just to make sure that... Just to see what we get there. Okay. So we've got our result, I suppose. So this is what we got. So we got 1, 1, 1, right? So I guess that's analog to here. 0, 0, 1, and then there's negative 2, 1, and then 3. So negative 2, 1, and 3, right? And then and then 1, 3, -1, 5. Wait, what? Yeah, 3, -1, 5. Yeah, this is all correct. So this is correct here, right? But then, I seem to be getting this step, but then this final step of extraction seems to be incorrect somehow. Just the way I'm extracting just seems to be wrong. Okay, so at least it's not too bad. Uh, so, hmm. So it's the way with I think it's the way I'm extracting. So I really thought that I could just put the colon there and that would extract it very easily. Let's ask GPT. Let's just quickly. Um, so if I want 3 and above, you would do. Okay, so let's just quickly. We're already declaring .show on it, so let's just see if it gets the whole thing first. Why does it sort of wait? So remove this .show. Yeah, so just does this. Why is it? Oh, cause. Yeah, it's just printing it row by row. But in this case, it's stacked as columns. The columns are normally it'd be columns like this, but it's sort of transposing it actually. Kind of interesting. But anyway, so we've got this. So now we'd only need the fourth one on. So let's just replace that with 4 onwards, and let's see what we get. Okay, so we get quite the results. Let's remove .show here. Just to get one answer. So we get 0, 1, -1. Yeah, so there's a problem with the way we're doing this. Okay. Okay, wait. Alright, we need to think about how we would go about doing this. Don't want to explode my 0 viewers there. Um, yeah. Okay, so we found the sort of error here. So what we can do is we can do we can do self.get columns, right? And we can literally even do, I think, this. What we need to do is call transpose on it. So we need to turn this into a matrix. And, oops. So let's just return the output just to sort of see what we get. Okay, so here's what we get. So the inverse we should be getting, I'll just read that out using a calculator. 0, 0, 1, bam. Negative 2, 1, 3, bam. 3, negative 1, 5, bam. Okay, cool. Yep, so it turns out, yeah, when you read the columns are stacked like vertically, so we need to just transpose it. Yeah. And when we did .show, we could have realized that, but anyway, yeah, we found inverse via RRF, determinant via RRF. Oh, dude, what? You can use the RREF algorithm to compute determinants much faster. Yeah, alright, bro. I think I'm gonna end this one here. I need to, like, I'm like, I do not think I got it. But it's really cool we've got going so far. And after this, we're gonna be starting K-means clustering, which is legit like the first actual thing topic. Uh, which is the actual first first I guess machine learning topic we're gonna be doing in this book. So the way this book works is we're gonna do it moves like rather quickly. So you're gonna start with just some k-means clustering, and 2 lessons later you're gonna be doing Hodgkin, Huxley, the model of action potentials in neurons. You're gonna be doing Euler estimation, not too difficult, but tic tac toe, not too difficult either. I mean, we've done some stuff that's very very similar, even more advanced. Uh, Here, hash tables. That's something I'd wanna I'd wanna do. I've always wondered about hash tables and if a hash maps, hash tables. Like I've always wanted to know what those are. I've never understood when people talk about hash maps, like what it is. But it's really good that we're going to be simplex method. Whoa, okay, yeah, that's pretty cool. I didn't even know about this. It's really cool because it introduces a lot of mathy concepts that are very important. Linear regression, very cool. Pseudo inverse, so cool. I guess you're doing your first neural network about here because you're doing back propagation, right? What else could you be doing for? Well, here actually. So decision trees, like this is all stuff putting from scratch will be a really good experience. But yeah, I think that's it for today, boys. Thank you guys so much. Yeah, I'm gonna take a little bit of a brain break. I always do brain break. I always hate when people say brain break, like especially when like in school and they say, okay, I'm all right, guys, all right, kids, take a brain break. But it's like most of these brain breaks, like I don't know, I just never liked the term because your brain, I mean, it doesn't particularly need it like a break where you're doing nothing. You can still do stuff. You can just spread out the things you're doing. Okay, yeah. Thank you guys. See you guys. Thank you guys for watching. If you guys have any questions or anything, you guys can just like message me. Try to, I don't know, my comments are getting blocked for some reason. Like you can't comment. But if you can't comment, you guys can like I don't know, email me. If any of you guys know me in person, just talk to me. I can walk you through any of the code. I can send you the code on GitHub or something. I think I made a GitHub repository, so maybe I'll link that. I think let me just check. Actually, while I'm at it, I'll just check. I don't want to keep guys waiting too long. I have to log into GitHub every time now. They made it so you have to do two-factor authentication to like log into GitHub, right? Seven. Okay, so I think let's just check our repositories. Oh yeah, but it looks so bad. And yeah, actually yeah, so you guys can just check it out on GitHub. The name like sounds really cursed. Uh, so I don't know how do I change the name? Settings. Yeah, settings should probably just be it. Okay, yeah. Rename. Okay, so it should be what should we name it? I think we're naming it intro exercises, sizes, and projects from intro to algorithm. Yeah, so all the parts are pretty neatly just like put in. You guys can just read over the code. It's commented. Um, like yeah, all the selection sort. That's all here. What's in part 7? Merge sort. Part 4 should be gradient descent. That's pretty cool. Part 2 is docstring exercises. Part 3 was I don't know what part 3 was. Actually, let me just check what part 3 was. How do I do this? Task enable taskbar or disable taskbar? Yeah, okay. Match chapter 2, part 3. Oh, I'm pretty sure like this was like what topic was this? Uh, this is part 3 of this, right? So, oh, I think it was new and Rafson method. I kind of skipped that. Like I've already done a ton of it. And I just didn't want to redo it, to be honest. Everything else is done reasonably well. Hello world. Yeah, GG